Okay, there we go. Sorry. All right. So, just doing some audio checks really quickly. Yeah. Okay. Yep, that's good. Okay. Boom. Finishing the setup. Okay. So today I'm going to be working on doing. So I want to get proper into the AI, and I did goof around a bit. And I was doing some testing just to see like the different things that Godot likes to do. So if it's not apparent, I am not unfamiliar with programming, but I am still acclimating to GD script in Godot. So typically what you want to do in these cases is, and just generally when you're designing anything in game development, is you want to have manager classes that are tracking your different controls. And you can sometimes in like simpler games get away with not using a manager class for different things. Like you can just make a game manager and then just have the game manager handling everything, pretty much, like where things are communicating through the game manager. So you just have like the game manager singleton class. And like it or not, the engine reflects what it wants you to be able to do programmatically, right? You're going to be, I can't say limited, but more like directed or punished if you try to go off the beaten path too far. So Godot, for example, doesn't do really any hand-holding when it comes to, well, let me just show. I think I have a version of it here. This is just like, this is stuff that's gonna definitely be refactored, but this is just me when I was testing out different AI approaches. So this is one of the ones that I found I liked. But I like this, but it could be better. And I just took that time that, because I was going to stream pretty much the next day, and then I realized my brain needs time to digest what it is that I need to do, or what it is that I have done, and what it is that I need to do. So I spent the time pretty much just relaxing, doing some extracurricular activities, and that's about it. So, for the most part, though, so where is it? Should be, yeah, there it is. Okay. So, like here, we do an emit, right? And this was old code. It's no longer viable. Well, it works. It's just that I'm going to change it. But we have to do call deferred, right? So this is Godot's attempt at handling timing, which is fine. In Unity, what we would have is just different updates. So if you wanted something to happen after something else, you'd actually just have the update, and you would have that update happen at that point, or whatever it is. Or you would actually just put it in the sequence, and you wouldn't have to worry about this being executed, needing to be executed on a call deferred, right? Because of whatever is happening inside of whatever is listening to this emit. It could be, for example, we're adding a child in this emit, and then this over here is going to want to do something with information that might include information around that child in some way, right? Instead of doing that, we have to do call deferred because of just how Godot handles how it adds children. Generally speaking, though, you want to do things in gaming where game development, I found, where you specifically have your initialization set up, and you do not initialize during the process. So in most cases, like in this case with the enemy spawning, I've already spawned, like the moment that you enter the map, I've already spawned, technically spawned all of the enemies. They're just not available. It's a matter of their situation. Like once their situation arises, then the enemies will spawn in. And or rather, they're already instanced. They're just not made ready for the player to be able to interact with. So that's how this is set up. And I prefer it that way. So all of the rooms, like when you enter the dungeon, when you see me enter the dungeon, all of those rooms are already spawned, right? It's just a matter of taking them out of the process loop, but leaving them in data. And that makes it so Godot is really only functioning on the specific room the player is in. That's part of the reason why I divvied out the, where is it? So this is like the room manager. And the room manager exists, think of this as right underneath the dungeon. So the way I have my setup, let's actually go out here, is I have my game environment. Now there is a singleton class above this for the game manager, but the game environment is basically the entire game. Once we load this in, it takes care of loading in the rest of the game. So the reason why I didn't just use the game manager to do this is because for things, well, not because, it's, yeah, it is because, I have a separate scene system for when you're loading into the game, right? Like the bootstrapper and everything that goes into the start game menu. So that's completely separate. That's completely disentangled from anything dealing with the game environment. Once you click start game and you select the game that you want to load, it'll unload that structure and then load in the game environment. Sorry about that. So we'll unload that structure and load in the game environment. Give me 1 second. Hold on. Okay, there we go. So for this kind of game, I find that this structure is good. You could do it in other ways. But so for example, we have the overworld that you've seen with the tiles. That's this area right here. Anything that's happening in the world happens on the world map. So when we interact with the world map and we go into dungeons, we actually just pause the overworld environment. Like we just hit pause over here. So we stop the processes over here. And then we start the processes in the dungeon environment, right? And you can see the UI environment over here is disabled automatically. And I've been told to try a different method with the UI environment. I like it like this, but I might try something else. Godot is really weird with how it wants you to handle UI sometimes, especially like in this case where the UI is childed to just a plain node. Nodes don't actually exist in 2D or 3D space. They don't have transforms, so they're just data. So to put this as a child of it, you have to do a little bit of finagling. So in my case, what I did is that every frame I'm updating the position of this in the world, which is something I believe what they suggested I do is I actually just use a viewport. If I haven't tested it, I'm just going based on what I've been told about how to approach this. So we set up a sub viewport here, make this a child of that sub viewport, and then just have the sub viewport stay centered on the screen, which I believe is just going to be the same thing. I'm just not using the sub viewport. I'm doing the same thing with the UI straight. So the UI environment is effectively functioning as a sub viewport. And I think I prefer it that way because I believe that sub viewports are effectively the same thing like when you're doing an additional camera. in Unity you have the a separate render happening there, and so I just said that's an extra layer I just didn't think I would need. If something happens with this, like if I'm seeing jittering or anything like that, then I guess I can give the sub viewport a shot. But right now it just seems like an unnecessary overhead to throw on. But yeah, so basically that's how it works. So we just disable the processes on these if we're not using them, but they still exist in memory. Now, obviously nothing is inside of the dungeon environment because we don't actually have a dungeon. When we click the dungeon, when we click to enter a dungeon, one is instanced for us, and then that's when the transition happens. And we transition over to a representation of the player in the dungeon, if that makes sense, right? The dungeon actor. And then all of the enemies get their own actors. So you've seen in the last video I shared the spawning mechanism for that, where we just go into the resources over here. One sec, let me hide this for a sec because it's getting in my way. You guys don't see it, but I do. There we go. Okay, so where is it? I think it's under. I should probably, you know what? I should probably create like an enemies resource specifically. But I think what I did is that I put them under locations, dungeons, enemies. Yeah, I might take these and then like put them someplace else. I'm not sure. I think it's fine keeping them here because these are really just used by the dungeons. Yeah. So that'll be clearer. So what happens is when I click the dungeon to try to enter it, I actually check the location, and then I check the location for the types of enemies that are going to be able to spawn there. So these are all resources. So the enemy data is the resource that's on top, that's inside of the location. So in this case, we only have one enemy in the game. It's our prototype enemy, right? And this guy's the enemy scene. That doesn't really have an appearance or anything like that. Its appearance is something that I'm debating how I want it to be set up. Right now, though, prototype enemy visuals. Right. So in the last video you saw when I actually set up, where is it? This. The enemy visual pack, where I added human, apparently. The animation pack. Oh, so we actually giving it an animation pack. I gotcha. Race human. I don't want to go into internally what this is doing. I've already forgotten what this does. But basically, it should parse some of this information somehow, some way. I should remember, right? You know what? Let's open this scene and see. I think that'll help clarify things for me. Okay. Okay, so yeah, this is basically what an enemy scene looks like. So we can put whatever we want on this. The idea is that when we do a creation on this, we'll immediately get rid of this mesh instance over here, this red sphere, and then replace it with an enemy. Whatever the visual is. It could be a dragon, it could be a human, it could be whatever. The animation pack is something that we have built into the database. So it's a data structure that I had made that allows me to get access to things like this using strings. So I just need to, if nothing exists, then nothing exists. Which now explains to me, because I was actually bewildered over the last couple of days, why do these enemies have animations? It's because I gave them an animation pack reference. Ha! I forgot. You forget more things than you ever learned sometimes, right? Um, so the this is what the structure of how to set up an enemy looks like. So now that we know, so this is the active player. So this is just default player. It's always going to look like this. I haven't set up any generator. When the game is actually ready to be tested out, like once I get it to, so right now we are in what I call pre-alpha. Once I get it to alpha, I'll have the character creator ready. So when the player starts the game, they can actually just create their character, and then from that point on, it's going to be pretty much I'm going to look for some testers to test out some of the stuff. But I figure that's going to happen by about maybe, if not alpha, then 0.5 pre-alpha, maybe even sooner, maybe 0.25, because by 0.25 we should be getting back into UI. 0.25, so 0.1 is where I'm at right now, which is the development of the so here's how it went. To get into pre-alpha, I needed to complete the gameplay loop. Gameplay loop is done, which means that we now have a game. Technically, it's a game. You can go, you can play, you can kill enemies, you can come back, get rewards, and buy stuff, and all this other stuff. But to get to 0.1 of pre-alpha, I need to get the UI to a place, or rather, I need to get combat done. To get to 0.2, I need to get the UI taken care of, so a player can actually just go from start game, click, create their character, end up in a world map wherever the heck they end up, and then go do that gameplay loop that I had mentioned before, and fight some enemies using the combat system that we are going to be working on now. And that's 0.2 pre-alpha for me. That means that we're on the way to now saying, all right, we have a valid game here. We have a system that can be developed on top of now, right? This is the baseline. So 0.2 is very important as far as progress goes. And yeah, that's it. So let's get to development, right? I've explained some of the systems. If there's any questions on my methodology or just code in general, I mean, there is a Discord link in the description. You can ask questions in the comments. I will try to do my best to answer them. But again, I'm pretty much not going to say that I'm a master at Godot. I wouldn't even say that I'm a master at game development or programming or anything like that. I'm doing what I can do, or what I know how to do. So if I don't have an answer for you, I'll let you know right off the top. Okay, let's see. But I've gone through a lot of pain, and there's still a lot more pain left, I think. I hope. Sometimes I hope. But there's still a lot more pain left to go through. So a part of this is enemy detection, right? So the player has over here sensor. And what sensor is doing, this is effectively how we are detecting enemies, right? The sensor is a sphere, 3D, but it's not always active, I think. If I remember, let's actually open up Free Flow Combat and take a look at what's happening with the sensor. Okay, so this is player. Oh, I see. Okay. Huh. I'm looking at what Pass Me did. This is a very small class. I like it. It's not much to read. Okay, I'm looking at what Pass Me did. So it looks like Past Me decided that free flow combat should be a completely separate thing from the actor. Like, divested it from the actor and put it as its own thing and just made it do it. And it looks like I'm using the physics process to handle everything. Right? Okay. Interesting. Okay, okay. Oh, this is bad. Because I had one thing in mind for how I was going to approach this, and now I see what I intended to do. Originally. Oh, gosh. So, I guess we can hit the state machine for a sec. So these are states that are being created. Right? So we're passing in the state, and then we're just adding these events to that state. And we do that over here in the whole passing in thing, if I remember correctly. Yep, here we go. Okay, so it looks like I had designed this with AI in mind. I made notes also. When in idle state, if an attack in a direction the player faces, search is maintained. When... Okay. Okay, yeah, it looks like I had designed this with AI in mind. Ooh. Okay. So there's another thing that I wanted to give a shot. I'm not sure if I'm okay with it though. That is groups. So Godot has this. Oh, where is it? There we go. Godot has this. Okay, yeah. So Godot has this, which are global references. Right? So I do like that they have this built in, and then I don't like it. Because they're using strings, and strings can sometimes create problems when you don't have static references. So I'm going to hope... Is this the right time to test this, is the question. I think so. You can learn along with me. I've dabbled with it a little before, and I've gotten certain things done. Like, what does this even mean, scenes groups? It means anything inside of this scene. Huh. 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 So what we could do is we can actually take the enemy manager and combat manager up a level. And we can bring them to the room manager level as children of the if I remember correctly. Let's take a look. So this is the room manager. So we actually can go up one level from this, which I believe is the dungeon manager. Dungeon environment. Yeah, right here. And if we take this up a level, then we can reference this. This is our enemy manager now. We have a static function for adding our active enemy. I didn't want to get back into the managers. I was okay with where they were. But, right, because you could always just do this to get the active manager, and then the active manager would then get the current room and get the enemy manager proper. Huh. Okay. If I do it this way, let's do some pseudocode and test out things. Static func. Right, and so now we can do something like what the heck is this doing? Set group. I'm confused. What does set group do? Sets the given property to the value of all nodes. To sets the given property to the value, that's this, on all nodes inside this tree. Sets the given property to the value? What the heck does this mean? Sets, I'm like, my comprehension skills are just like shot right now or something. Sets the given property, this, on all nodes inside this tree, added to the given group? Huh. Let's check out groups real quick. See if there's any documentation from it. Huh. There's a lot of getters for groups, but I could have sworn you could add a group to groups programmatically. I think I've done it in the past. I just don't remember it. Let's just try doing... Ah, there we go. It's on the node itself. What does that mean? Persistent. Adds to the groove. Oh, okay. Yeah, we don't need to keep it persisted. Okay. So now we can just do this instead of this. Instead of subscribe actor. And then we can do this. Right? We don't have access to this right now. So when it's on death, we go we want to unsubscribe the actor. Okay. I don't think this is even necessary, but okay. And so now this can be that. I like this, actually. I like this a lot. Yeah, this is nice. It feels okay. Is the game running? No. That's weird. They're giving me a ton of errors. I don't think this is gonna work. I don't think you can cast array like that. The compiler says you can. It's not giving me an error anymore. But I don't think Godot knows how to handle this. I don't think it knows how to handle it. There's a safe way to handle this. No, hold on. Can we just do this? Oh, no, we can't, because it's a static function. So... I forgot how this works. Filter. Gotcha. Wait. Yeah, pass it in. I think we do a return. Yeah. I think it's vector 3i. No, I think it's vector 3. Map position, that's what it's called. Okay. Okay, there we go. I wonder if we could do it this way too. Like, I don't know if it'll handle it in line. Let's see. Huh, looks like it'll do it. I don't know what all of these errors are, though. Scene, main node. Sure. But I don't know what all those warnings are about. That was weird. Okay. It's anyone's guess if this is going to work, but that looks cool. Okay. Ooh. Water. Okay, so we don't need this anymore. Actually, let's... right. So we don't need this right now. Or actually, let's do it this way. Comment that out. Because now enemies don't need this. We can do it all here. That brings me to this. In .NET, what's that IDE? The one that Microsoft put out. I haven't used it in so long I forgot the name of it. Holy cow. But it's it would just allow me to click this little area over here, and I could go to all of the scripts that in let's do some stuff. There we go. So instead of this, we can just do did we save? Let's save. Okay. So now we can just do subscribe. There we go. And then we subscribe the actor to the entity manager, which is basically just adding it to the group and connecting its on death. I think what I want to do actually is make something else. Hold on. Oh, we do have on after death. But we don't want that either. We want... And actually, we want to pass in the dungeon actor. This is more of a system, so we're not going to broker this. And I think we can get rid of unapplied damage. I'm pretty sure we're not using it anywhere else. Oh, we are. Is this a thing? Oh, we're using it over here. But nothing's listening to it, right? We are emitting. There's no .connect. So I think this now is gone the way of the dodo. Right. So what did we replace this with? Hit area. Combat manager. There we go. Right. This needs cleaning up. This is our damage applier. It's still functional in the old system, but I've refactored that system. This is... The refactor would drastically help this, I think. Because now the combat manager is basically handling all of this information. Right? Like, all of this was made because I was just testing stuff out. Okay. So let's start by breaking this, and then we'll fix it along the way. So first we have that. Right, so this gets passed in an event from where? Okay, good. Good. Okay, I see the problem. Oh, no, we could just do this. I think this has a... Yes, it does. Awesome. Yeah, I know. Sometimes Past Me does things that's just, like, amazing. Oh, okay, so this is now duplicate damage. So now when we're changing stuff, we're not messing with the original damage. That's good for, like, if we want to have stuff like combat logs, right? We can just tap the damage, or, like, later on I could just store all of the damage objects and then parse from them a combat log down the road. Okay. So we need... Okay, I see what the problem was, or what this was trying to do. It's trying to insert its own information, this stuff, which is why it went through all of this process. But I don't think it needs to do all of that. So let's do this. Toggle. Okay, So we're just gonna do this. Okay. So the first thing is everything here is cumulative in the evaluate attack. Right? It should just be adding to it. So all we would need to do is just plug in the base numbers. So we already created a new damage, right? No, we didn't. So let's actually do this. Okay. And then the rest of this now is just shorthand, right? Make it more readable down the road. So now we have the attacker and the attacked and the attacked. So the next step is we want to plug in this information. So that should be linear. Damage. Nope. Type. There it is. Oh, what? I don't even know if we need to do this anymore, but whatever. We'll remove it if we don't need it. Yeah. What is going on here? There we go. Damage type. Wants to know, evaluate wants to know about the ability, though, doesn't it? How did I handle it? I think I did it in a pass by. Let's check over here. In project, where is it? Should be. Where the heck is it? Define damage. So this is not going to have an ability on it, is it? No. because it's just an effect that's ticking. So if ability. Just do that. So if it doesn't have an ability, then it'll just proceed with the damage without trying to apply the ability modifiers to it. Obviously. There has to be a better way to apply this, though, right? No, I think that's it, because we need to actually call the ability after we call this. Otherwise, yeah, so if we don't have an ability, then we handle it differently. Yeah, if we... yeah, I think that's good. Alright, so let's go back. Oh, I traveled a long way, didn't I? There we go. Okay, and then... the damage. Amount and knockback. And is this right? Okay, yeah. One sec. Attribute data. Gotcha. What am I thinking? There we go. Okay. Well, I was in the right area. Okay, so basically if I just throw a string in here, it'll handle it this way. If I throw an array in here, it'll check to see if that array contains attribute data or for strings, and it'll handle them accordingly. If it doesn't, this doesn't have anything in it, then it'll just continue through. So we should ignore bad values. I know it's only me working on this project, but it would still be bad if I forgot something. This is like my game development for dummies. Because I am a dummy. For sure. Okay. So now we can do attributes.add. And we can just push in the target attributes. And is that it? We put in the type, amount, knockback. Yeah, I think that's it. Now by default, for now, these are the same. But down the road, things might change. Where, like, if I make like an ability that specifically is going to, like, let's say like this wants to do apply damage, but it only wants to apply it to health, right? If we do it this way, when it does damage, it's going to try to apply aura damage first, then stamina damage, and then health. If we just want to do damage to health, then we can eliminate these two. Right? That would be a pretty lethal ability if we did that way. And then we don't need to worry about the rest, because evaluate attack is going to handle the rest. Or it should. Holy cow. But we can now see what the rest kind of looks like. And we just push the damage through. I'm surprised it wasn't breaking. Like, it should have been giving me a ton. Oh, it probably was. It's just mixed up with the other warnings. Yep, that should be doing it. I'm not gonna delete. Yeah, this is all useless code now. So we'll also be getting rid of this. And this is going to become a static call. Maybe. I didn't intend to go here, but we fixed this. So now we can come out of this. We don't care about the player right now or the hit area. We were looking at free flow, and we were actually in the enemy manager and refactoring it a little bit. Okay, so this was doing a try add target. We don't need this anymore. I don't think anything was using it except that. And we're about to get rid of these two. Nothing should be using this. Anything using this is the question. Nope. And nothing should be using this right now. Okay. Yeah. Okay, that looks good. Yeah. Oh, right, we were in the middle of this. So we're not actually looking for this on after that. What we're looking for is on actor cleanup. And this is going to be passing in we don't need to pass damage in here. I don't think we need to do this. I think this all happens on queue free anyway. But just in case. So when we go to clean up the actor, it should handle this part. Depending on how this works out with groups, I might just make persistent entities use groups as well. Now we wouldn't need to do that anyway. Yeah. I don't think we need this anymore. Okay, at some point you're gonna... Yeah, there we go. Oh boy. What the heck? Hold on. Weird. I'm misremembering something. Okay. I didn't misremember. My eyes are just didn't scan all the way up. Should be over here, right? Player, actor. So now, this is more than I wanted to do with this. My question is, can this become... I think this can. Hold on. I don't see why it can't. Can it? Yeah, there we go. What did I just delete? Print. Oh, it's just a... These, sadly, they can't in this form. I mean, I could do the work and turn them into it. Right? We could. Wouldn't be too difficult. This one kind of then gets a little lengthy. Long in the fang. What's the benefit of doing it that way? We'd only have one combat manager. Right? This. One combat manager to rule the model, and an enemy manager to bind them. We wouldn't need to worry about map ID. But this is a node. Is the enemy manager a node? Oh, it is. A node with a ton of static functions. The only reason why this is a node is because we needed that ready. Are there any processes working? I mean, we could extend this later on because it's a node, so we're gonna keep it like that. I mean, there's certain things that we don't need to think too hard about. Well, we could just do that. Yeah. If we do it like that. It'll give me a nice warning down there, but that's fine. You don't need to worry about this anymore. Let's just check where it's being used. Nowhere. Awesome. This is being used somewhere. Okay. So we can get rid of this, all of this, all of this. Okay, so we don't need to worry about this one. This is, this is going to be subscribed. So we could actually just do this in ready. Right? Yeah. Okay, so whenever we make a new dungeon, we just need to tell the combat manager to initialize for the new dungeon. But wait, there's more. This is happening on, right, because this is actually a new entity every time. So we have to connect it. Gotcha. Oh wow, that was easier than I thought. And we just need to do this. There we go, refactor complete. And so now we don't actually need to use this. Okay, so now I think we can get rid of this. And there's one over here too, right? Yep. If we do somehow need to make functions inside of this, that we can. But I think this is a good way to set up groups now. What other groups did I make? Entities. Yeah, we're not going to mess with that today. This is for like persistent entities that on the world is what I was thinking. If this works for regular enemies, then it makes sense to do that. There should be hold on. Do we even need to do that? I mean, just in case, I guess, right? It's always good to have what? Doesn't this return bool? It does. Oh. Oh, yeah, the name. Right, so all this really does is just lock type safety or syntax. So if I don't need to worry anymore about typing this in incorrectly, basically. All of that work just to make sure I don't make typos. Well, I mean, there's more to it, but still, this is giving all of the functionality I need. I can update the state of all of the entities here and stuff like that. So let's remove Okay. Yeah. Yep. Let's test this out, see if it works. This is always the scary part, right? This part should load pretty fine. I didn't change anything. We got some warnings. Before we go in, let's see what that's about. Parameter room. It's called, but never used. Oh. Yeah, we never had to use these. But local variable defender declare. Oh, okay. Okay. This stuff is just annoying. Integer, so segments is an integer, if I remember correctly. Okay, let's cast it. This is, we have to cast it just to get rid of the warning. That's kind of annoying, right? Yeah, but it is what it is. Okay. Let's load this up one more time. Oh, I don't even know if this is showing on OBS. All of the warnings are gone, which is nice. All right, let's go. Make this bigger. Hey. All right, time to crash. Nope. The ground looks bright because I have the debug on for the, yeah, these guys will just patrol on their own. Yeah. There's certain things that I want to take care of, like you see how these two got in ooh. There we go. We got in each other's way. So that's something else we're going to work on today also. So before I actually hit that though, I'm going to, from the ground up. Well, first off, it works. The subscribing and stuff like that. Let's actually take a look. You guys aren't going to see this part. Promote. Grr, it's not showing. Inspector. No, it doesn't show it. Does it show you the groups at all? I have to do a test on groups. Okay. I just need to find a script that's always running. And let's minimize this for a second. Okay, so I just need to find a script that's always running on this and just test the group size. You see it's printing out a whole bunch of information about what the enemies are up to. Enemy dungeon active. Here we go. Let's get rid of these because we know these are working. I think it's going to give me an error though. Actually, those are the wrong ones. We want those there. The ones that we want to remove are this. I think it's further down. There we go. Okay, and then over here now, we can do this instead. Print. Get enemies. Let's do this one first. Okay, if it doesn't error, then we should get pinged, and I think it errored. Yep, it did. Yeah. What did it error on? An array. Enemy dungeon actor. Array node. Let's try doing it this, like this. Let's try that one more time. That was the other part of it that I wanted to test out, to see if it worked. If it does, that would be pretty cool. But I really don't think GDScript allows you to do that. I think the compiler will say, hey, that's fine, but as soon as they start trying to... Oh, there we go. Yeah, so the compiler will say that it's fine, it knows what I'm doing, but then GDScript will just blow a gasket. I mean, I could just do this. And then GDScript will figure it out on its own. As it does voodoo with variant types, I believe. Nope, Nope, it doesn't let me do it. Alright. So we have to do it the way that we had done it before. Okay, now let's give it a shot. That would have been nice if it worked. Yeah. It is what it is. Okay. We got a debug warning about the sizing of the map. Hey! Okay. So yeah. Oh, there we go. So yeah, it says there's total of 25 enemies across the 5 maps, which makes sense. 5 times 5 is 25. And in the room, we only have 5. So let's defeat an enemy or two and see what happens. Oop. Something happened. Oh, ability. Ugh. Yeah, I missed that part. So right here we try to get ability, but this thing doesn't have an ability to be gotten. Alright, I guess we just have to do it this way. I forgot. I think it's a material. Matter. I could have sworn this was a static call. Check. Oh, I think it's element table. There we go. Okay. Okay. All right. Now let's give that a shot. What had happened was we have the ability that just went off, but recall that I had blocked off access to abilities because it doesn't have its own ability. It's just an effect, it's burn effect that's supposed to happen after you hit the target. So, in that case, we just want to ignore. Okay, and it's doing damage. Okay, let's stop. How many? It should say 4 is in the room now. Yep, it says 4. The rest of them break because they change their states to, hey, you get to see the damage over time working. Huh. Nice. Okay. Yeah, they get locked into a combat state, so they don't know how to get out of that state. But yeah, groups are working. We only have one person, and there are only 21 enemies. Okay. I think I'm happy with how that turned out. So let's get into the AI now, proper. Yeah, let's do that. Let's get a little water. Okay. So now that we have the boilerplate done for the AI to communicate back and forth between the player, the scene, and everybody's all up on the same page here. Let's just what, combat handler. We can delete this. Yeah. Okay, there we go. All right, save. I think we can close that. Combat manager. Okay. So now we just need to fix one more thing. Where is it? Room manager. This is no longer here. We're gonna go up one level to the dungeon environment. And this is where this is. Oh, oops. There we go. Okay. So this is a node. So when we do ready, we do that. And we add them as children. Okay. And then we also have that thing that we need to do with the combat manager. Whenever we start or we enter this dungeon. Where is that call? I think this is it. Start location, yeah. So let's wait until the end of everything. Actually, no. I think we can do it inside of the, I know where we can do this. I know where we can. Player. And let's do it first, because it doesn't hurt to do it first. What did I name it? There we go. So whenever this gets initialized, we also initialize it inside of the combat manager, which basically is just for now connecting its on death effect to the combat manager. Yep. Oh, forgot something. There we go. Okay. So now we have the boilerplate done for the AI. The player will now be updated, or the current player will be updated, so if the player dies, this is down the road stuff we don't need to worry about. This is some extra tidbits that gets the player to actually display and run its animations properly. We won't get into that right now. We're going to move into, finally, fixing the AI up. So my approach on this was, can I make this better with resources, right? So let's actually, it's closed already. Let's actually go to the, do I have it open? No. Enemy actor, dungeon actor, there it is. No, that's the, oh, there we go. Enemy dungeon actor. Okay. So let's move these things around. All right. So I was debating if I should make a resource or a series of resources, right? For each one of the different patterns, expose them on the inspector for the enemy dungeon actor. So they would be appearing here, and we could have one for how it should patrol, how it should engage, and things like that. I don't think that would be a good idea, right? So this is where things start to get a little bit, this is where you always hear that term spaghetti code. If you've ever heard it before, that's where it comes from. It's when you don't take the time to refactor, as we just did, you end up spaghettifying everything. So we also end up spaghettifying when we do not spend the time to play out where the heck does this next plan lead exactly. And I could say that a solution tends to be just looking at how the developers of the engine did something similar to what I'm trying to accomplish, and then backwards engineering that to figure out, hey, if they did it this way, then there must be something to it, right? So let's take a look at the navigation agent, right? Typically, Godot, they want to, they usually put like a resource in, right? See, I already forgot something important, which was that past me already had a plan. Let's go back to past me's plan. I just remembered. Past me had a plan. It should be in my free flow combat. There it is. We had these. And we had these. So past me already knew future me would be incompetent. So past me wrote these things out for me. Alright. So I've gone over the state machine in a previous video on how to make it. The one that I made in that video was not as robust as this version. It's still the same premise, the groundwork is still the same, it's just that this has a lot more going on inside of it. So I can dynamically create states. Like I can just do add a new state and create a new state altogether at runtime if I wanted to, right? So this is great for like inserting new kinds of logic. We just need to make sure that we, inside of that state, include some method of transitioning out of that state. But the state manager is what would be considered an event-driven finite state machine. It's a mouthful, but that's basically what it is. And so here we have the beginnings of what passes for AI. So the player also uses this. Because in some ways, when it comes to combat, dealing with this stuff as a player is kind of similar to how the AI is going to be dealing with it as well. But before we can actually do any of this, we need to make sure that the AI is properly detecting the world around them. Right? And so we built this out for the player as well, player free flow. And over here, we have a physics process that's just running. Why is this just running? Oh, this is just to see the okay, so gotcha. Gotcha. Okay. Yeah. What's this do? I see. So I'm doing this every frame. Every physics frame. So this is what I'm thinking. We're going to go to the combat manager. Where is it? And granted, we could do it through game data, but we want to just make it one simple call. Right? Let's just make sure this is what I think it is. Yeah, okay. I consider these things kind of like skin suits. The entity is the brain, but then it changes its suit every scene. Huh. Alright, so now that we have a method of just getting the player from the combat manager, the enemy... Wait, how's that active dungeon? Yeah, that makes sense. Okay. Okay. So this is what I was thinking. The enemy will always know about the player. No. That would work if we're going to make a game where only the player can be the enemy. But the idea behind this is we're going to be having a bunch of... Like, the player can have their own kind of like a crew kind of situation. So you can give simple commands to your crew and they're going to be able to run around and fight and assist you and do things like push this block over here or stand on this tile or defend this location. Things like that. You can give those commands and then they'll try to defend that. Like, you'll bring your mouse over there, say defend that location, and then they'll go over there and defend like that choke point, and then you can go fight enemies on another choke point. So that's how the game is supposed to be set up down the road. So we want to give the enemies the ability to develop an aggro, and so we want multiple things. Huh. So what if I instead made a combatant list? Right? If the combat manager had a combatant list for itself, similar to what we just did with the enemy manager, and it simply has all of the combatants. That's a lot. That's a lot. I mean, it's nothing if it's just a player on the combatant list, but it's still a lot. And I don't like that. Down the road, that turns into a problem. It would be good, though. Short term. If we had the combatant list and the combatant list had everything, though, both the enemies and the players, that would eliminate that down the road problem I was just thinking of. Where, what happens if, let's say, like, we confuse an enemy and now it can attack its friends, right? No, actually it wouldn't be a problem. We can just tell it which list to check. And then handle that logic itself internally. Okay. So, yeah, I think we want to make a subscriber for the combatants as well. And then every frame while it's patrolling, it'll check to see if the combatants are within range, if any combatant is within range. And if it is, it'll add that combatant to its aggro. It'll just give it some aggro value that decays over time, right? If they don't see the target, the aggro will start to decay. Or if they're engaged in combat with somebody else, that the aggro on something else will start to decay. I don't like it, though. I can't think of a better way to do it. Okay, so we're going to create a new script. And it's going to be called, it's basically we can call it the sister script, or brother, whatever you choose, to the parent, where is it? To the player through flow combat. Let's actually close some of this stuff down. We have a ton of things open. We don't need the room manager open right now. We don't need that. Actually, we needed that, but whatever. So let's refactor this a bit. And basically what this is going to be, wow, it has a whole ton of stuff that this is all just me working on stuff, just testing things out before this video to come up with like a idea for a system that I would like. I'm gonna just do the work of, there we go. Okay, yeah. This is the way I wanted to do it before I realized that I had made a way to do it. Okay. Okay. So, let's make an AI. So state cooldown, usually you want to have some type of cooldown between when you're transitioning between states, right? That way you're giving your AI enough time to complete whatever action it was doing and then move into like the next thing that it can do. We now know that we're going to divorce combat-related stuff from the dungeon actor. Like, explicitly combat-related stuff is going to be taken out of this and then put into the new script that we're going to be making that's going to extend free flow combat, but for the enemy. But there is still stuff that needs to be taken care of here. So the first is we're going to have our func set entity, which is basically this. I think we can get away with just copying this, I'll be honest. I feel like we can just get away with copying this much. Okay. Yeah. Okay, so now we have animation. So this is just assigning the animation pack that we've gotten from the gender and whatever animation pack we were told that we were using. So it's just going to try to find an animation pack that matches that gender. In this case, it's human, but it can change based on whatever enemy data we put in. I showed that at the very beginning of the video. See, it's all coming together a bit. Or the very beginning of the stream. So now we do set entity. So in set entity, the agent is already there. So we get our enemy data here. And we also need to do the subscribing. So after we've done super entity, we can do entity enemy manager scribe self. Right there. So now this is registered to the enemy manager. Next we can do, so now it's inside of the group. So now next we want to keep this as simple as possible. We don't need to worry about aggro or anything like that. Cooldowns, heck, I don't know if we even need to worry about this state stuff over here. But we do need to have quick access methods for the agent. So let's do one. Func set destination. So then we pass in the destination vector 3. So this is like just the Unity version of this. And we have set destination down here. Yep, here we go. So we could probably just get away with copying this also. Yeah, and so we can get rid of this. Okay, so now at the parent level, there is a, if you're wondering like what magic is actually making these objects move, because we're actually using a floating capsule, which is a rigid body in Godot. And so what's actually happening is once we do set target, there is another script inside of this. I can just show it. This right here. AI direction controller. This is what I meant about like how the Godot ways, they wouldn't just normally insert a resource. So I could insert whatever resource. So let's say that I inserted a player resource here, right? Then the control methods would be listening for my inputs, for my keys, and then suddenly now I would, the player would be the one in control of this enemy, right? Like moving it around and stuff like that, and things like that. But in this case, though, we're not completely divorcing these two systems yet. Like the system for absolute control is still sort of tied into the player, just like how we're sort of tying in the system for control here with this. But down the road, I'm setting this up so that way down the road, if I decide that I want to like just randomly swap at runtime, it shouldn't be too hard to refactor this so it can do that. Right? But it's easier when I have like a bigger picture in front of me already painted. So we set the destination. So we set the target here. I'll show you what's happening inside of the AI direction controller that'll let you know like how it's operating. I just gotta figure out resource. Okay. AI direction controller. There we go. Okay. So we can actually just get rid of this. It's just me testing stuff. So yeah. Basically, it's just two very small scripts. We get the look at point, right? And this is being called every physics frame. It's being called from inside of the floating capsule. So let's go to the floating capsule. I'm not sure if anybody wants me to describe exactly what's happening here, but I'll do a brief description. So first, when this is called, we pass in the entity, and then we just do a little bit of vector math. We first have to decide what the destination is. So if the first thing we're going to do is try to get the next position. If there's no next position set, then it's just we're going to return the entity's global position. But if there is a current target, in other words, if the enemy does have something that they're trying to attack, then we'll just use the current target's global position. and then we set that as a destination, right? And then over here in get direction, this is used by the thing that is trying to apply vector force. So if we have a nothing, if we're returning, if navigation is finished, right? In other words, we're not being told to move anywhere, then we return vector 3.0. Let's actually do something here. And right there. So I'm not even sure if this is necessary, but I think I could probably just get away with getting rid of this. I'll be honest. Yeah, I think we can get rid of this. Pretty sure we can get rid of this. Right, so every physics frame, floating capsule is going to be calling get direction, get lookup point. The player works similarly. I won't go into the player's one, but basically it's just parsing the type of controls that the inputs from your control, mouse or keyboard, whatever it is that you're using, and then just parsing that out into 3D space. Yeah, so see, I look at stuff and I'm like, oh, I could clean that up. Anyway, the floating capsule is doing this right here. This is it. So we have neutral movement pack, which is something that is just, this is for the state machine on the entity or the actor. When we're in neutral state, then it's using this pack, and we just set these packs up along the way. But this is where it's actually pulling the information. So we're going into the input method, just getting the direction, passing in the actor, and we're getting the direction that way. And then we're just applying forces. So we don't need this right now. This is gone. Okay. So in-action movement pack and stuff like that. So over here we just have some static numbers that we... Oh, they're not static. Actually, you can change them based on your stats. Like if your move speed is faster, things like that will affect this. And then we have the physics direction. So this is actually just translating it from 2D space to 3D space. For rigid bodies to be able to figure it out. We have our floating capsule script here. Pretty simple rubber banding. I'm gonna go over it slowly, so in case somebody wants to just copy it down or something. Then we apply the movement. So this is actually what applies forces. And so now you're saying, well, wait a second. Your dungeon actor is very clearly not a rigid body. Oh, floating capsule is right here, right? And this is inheriting rigid body, sure, rigid body 3D. But you say, wait a second, rigid body 3D, how is that working, right? Like, where's that? Where exactly is that influencing this? Well, that's over here. Every physics frame, every process frame. Is it? Yeah. We do run delta, which is basically just going to set this position. We can do this outside of the physics process because we're not messing with physics here at all. This is set to top level, and so this will just continue to follow the rigid body, the capsule around frame by frame. We ensure that we don't have to worry about much, really, just by doing this. It's pretty simple. Technically, we could actually just get rid of run, but I kept it here for different reasons. Like in case I wanted to put like a state machine on this or something like that, I could do that. Hey. Oh, son of a gun. Can I undo that? Whatever. So we have free flow combat. Let's go back to it. Let's close. Yeah, save. Let's close that. Let's go back to the dungeon. Enemy dungeon actor. Okay, so we have set destination. And once we set the destination, so now movement is done. As far as we're concerned, this thing can move around. The next thing that this wants to know about is from its free flow combat. So let's actually make a node here. This is what the enemy dungeon actor. So let's make a add child node. Free flow. Uh-oh. We have to make the script. Actually, hold on. Yeah, we have to make the script. So let's go to free flow. There we go. Enemy, or actually let's call it AI. There we go. Okay. So because we're borrowing from free flow, I think free flow has its own AI, its own state machine, right? So, and then in order to get access to that state machine now, we can just populate idle, search, engage, and disengage. So AI free flow, it wants to take in a detector shape. Okay, add. We're going to add a child node. I think it's a shape cast 3D. And we're going to give it a new sphere shape 3D. And we're going to call this. What did we call it for the player? Sensor. Okay. You know what? Let's just grab the one from the player. Because it's set up already. I don't need to worry about stuff. Delete. Okay, good. Alright, so I don't need to worry about like size, and I know that this one is... because there's like settings on it. I mean, if you want, I can go over the individual settings. But there's like settings on it that you kind of need to handle ahead of time. So now the dungeon actor, I know, does the dungeon actor have a slot? Let's see. Okay. So let's actually do that here. Okay, good. Now we have access to that. Okay, so now AI free flow is coming together. Stick with it, right? So And actually, you know what? We're still testing, so let's not do that. Um, so now we have a set destination. We need to let the AI free flow control enemy detection. I think I'm going to do it that way. Let's take a look at how... That's the one that we just closed. Gotcha. Let's open that again. There we go. I was trying to remember what I closed. So we listen for an attack. So we do set target locking, which is this. Find target in direction. So this is going to be a little bit different, right? Gotcha. Gotcha. It's going to be different. Mm-hmm. Mm-hmm. Then we do find target in direction. We could actually just use this. We can reuse this script and just set the vector, set the distance to 0. Yeah, let's do that. Okay. AI free flow. So what we're going to make first are the helpers. These are the things that are going to actually be putting inside of the states. So func, this is going to be happening. Actually, let's make the func, so this is just going to return an array of dungeon actors. Right? And it's going to... Wait, can I actually reuse that? What is it going to be looking for? It's looking for hurt areas. Does it parse it for anything, or that's just it? I see. We can't use this. Well, we can't use this because this is going to return a single thing. So let's actually break that apart. Gosh, that's a long signature. Okay. um, you know what? Let's make this bigger. There we go. You know, I was rewatching this video, or not this one, but another one, and I realized that the quality is a little bit low, and I was trying to find out like how to change the recording quality. But admittedly, I didn't delve too deeply into it, but I think next time I will definitely try to see if there's a way to, I mean, because I'm not really like running tons of stuff right now, so I should be able to get 1080p, no problem. I mean, if the text is too blurry, then, I mean, let me zoom in a bit. Hopefully that's clearer. Let's hide it. Let's get rid of this. Okay. All right, let's get back to it. So we want to find targets. So the idea behind this is that we're just going to take this method and just break it into two, right? So in this case, we're just going to grab this. Oh, I see. Sorry, give me 1 second. I'm just trying to parse what I'm doing here. The result is a dictionary. And the dictionary contains another dictionary. Right. So right now we're parsing a dictionary to try to get to that. But in order to get out of that, what we can do is... Okay, gotcha. Ah, right. Right. Okay. Then next we go... Okay, yeah, it's expecting herd area. Got it. And let's bring this out here. Okay. So now, we go here and we say do we need? I don't think we need extra origin. Why? Because extra origins when we want to narrow down what we can get. Okay, gotcha. Oh gosh, it just created a bigger problem. Oh boy. I mean, it's still a valid script. I'm going to keep it, but we just need to change things a little bit. We can actually just copy this. I gotta find out what this thing is returning. Shapecast result. What the heck? Is it collision result? What am I missing? Oh yeah, it is. Okay. So it's an array. Gotcha. Let's go back to AI free flow real quick. So we technically have what we need already. So there's no need to get into this. Actually. Just make these two completely separate things. Yeah, and this doesn't need extra origin still. Okay. And so there. Now, while idle, I'm thinking that the AI doesn't need to check around it. So it's not going to, like, unless the player is like in front of them or something, they Yeah, okay. Get in range targets. So var targets is going to be equal. Did I save? There we go. Tools. Grr. I don't remember the name of it. Hold on. There we go. Grr. There we go. Okay. So we don't want this. And I wish Godot. Had that. This is where an interface would have been really nice. Okay. How about this? Now, a keen eye would say, wait a second, this doesn't exist. Hold on. Later on, I'm going to make this a bit more verbose, but yeah. Okay. This is just like where I'm putting my extra stuff until I'm ready to sort them. What's the issue here? Ha, you're so smart. Okay, so this will, or should, now try to get enemies in range, sorry, around the AI. We do, however, need to initialize the shape a bit. Does this have an initialize already? Has a ready call. Now I have to do it this way because if you execute this before from ready, this will actually execute after this because this is happening over here. So I just tell it to call defer to wait until after this, basically. Now, if you're using my state machine, then that's a thing you have to look out for when you're using it's. I've only encountered it when I have to deal with ready, but it's fine because technically this should be getting created, and this should be getting created before we actually try to initialize anything, but it is what it is. Ready is just weird. For me, anyway. Okay. So this should now just transfer over to idle. And then idle... Oops, wrong. Enemy dungeon actor. There we go. What other helpers do we need? So the AI free flow is can get targets in range. And then once we find that a target is in range, we'll want to check with the combat manager. Or actually, no. We'll want to ready. So we want to change our state to a combat state. So we want to tell this. This wants to tell the actor, hey, it's okay to change to combat state. Wait. So first we need to actually detect if these enemies are in our range, and then if they are, can we actually see these enemies? Right? And then once we've seen these enemies, so we actually need to do this. This would be our aggro list dictionary. All right. So maybe we want to make this an object. Let's do that. Should we make this a node? I think we should make this a node. Or, hear me out, we could make this work on the dungeon's internal clock. Let's try it. Why is it doing that? Equals... No. Oh, yeah, no. Or, oh, no. What the heck? What did I do? Ah, it's this. Yeah, now it changed. Okay. So let's just test to see how we get to the internal clock. Yeah. I know it's in the dungeon environment. I'm pretty sure. Where is it? Dungeon time. Here it is. Do we use it in other places? Wow, this is old code. I haven't touched this at all. Enable time. Let's see what's inside of dungeon time. Might have something that we can just access directly. Okay, so this tick is... Gotcha. Okay. And what happens on tick? Okay, so we can actually just get to it from the game manager. We can use early tick, tick, or late tick in dungeons. Past me, bro. He was a person ahead of his time. Okay. I don't like getting to it through this, though. But I get what's supposed to happen. I'm supposed to do... You know what? Let's do it this way. Because I don't like doing it that way. So that just means that we need to build an API out. Dungeon time. Oh. Okay, so now we do a match. And we take the Does it oh. There you go. Should you? Yeah, I think we should. Okay, done. So now we have a method of getting in and out of this thing. So I'm not sure if we'll ever need to use this, but it's nice to have it, I guess. Oh. Oh. All right. So now this is like just to test this out. We're also going to do this for now. I think I want this to be a node. We can actually just do this. Yeah, I like it this way. So now we can do this. Did I save? Oh, there we go. This is the Godot way. This should expose it over here. Right? And will this run? Can I test this out right now? No reason it shouldn't run, right? Is there anything looking for it to have? It's not it shouldn't be. This is pretty encapsulated. You know, it's a good thing to test this to see what might be like around and doing bad things that shouldn't be doing, right? Because there's nothing in it right now, so it shouldn't break. If it breaks, that means that we have entanglements we probably want to get rid of. Or if we do, there needs to be a very good reason why we have that entanglement. That should be a fairly encapsulated class. I mean, what's the worst that could possibly... Maybe like with the setup, like when we're actually spawning it in, it might be looking for information back from it that it won't set up. This is the only thing I could think of. Nope. Nope. We have loaded in properly. We have a ton of errors happening though. On actor cleanup. It's already connected. Why is it constantly trying to... Like constantly trying... Ah, weird. Oh, I know why. I think. Error calling from signal early tick to callable. So it's expecting an argument. What is that argument? What is it passing in? I'm not passing anything in here. Right? Oh, it's passing in the event. Gotcha. Okay. Where is that? AI aggro. Event. Okay, that's one. What is the other problem? On actor cleanup. So something is happening here. Is already connected to the given callable. Okay. Okay, so we're doing it twice. We did it once here in Enemy Manager. When we finish the spawn, and then we do it over here when we set the entity. So we can just get rid of this one. And this is just it ticking because we needed to supply it with that argument for event. I forgot it passes the event for the actual time if you want to query information about the time each frame. Or not each frame, but whenever the tick is called. Okay, it's working. Going slow, but it's working. Okay. So now we have the method of decreasing aggro over time, and we know it works. Now that we've made this a node, do we even need to do that? I don't know. Do we want it to decrease by tick, or do we want it to decrease every frame? I do like that this is so easy to set up now, though. Let's do it by, yeah. So now that we know that this works perfectly fine, and we set this up as a node anyway, I think it's better to just do it this way. But that's nice to have, though. That's a very handy thing to have. Oh. And we don't need this anymore. Okay. This is tested. Okay, so now we want to just go about the normal stuff. We want to add stuff to the list. Okay, so we need a couple of things to be tracked. The first thing, I believe, is going to be the last time that we saw the enemy. Okay, the next is going to be the intensity of the aggro. Anything else? We want to know the last time that we saw this entity, and we want to know the intensity. Actually, hold on. I didn't delete it. Yeah, let's see what I did before. Like I said, I had tested out some stuff to see, hopefully make this a bit more on sufficient. I think that's it. Actually, Okay, there. So if it's a ranged attack, it accumulates less aggro than melee. Yeah, okay. This should probably pass in Delta. Okay, good enough. Okay, so now we have our aggro system. We just need something to handle this. One sec, let me water. Okay. So we could actually get away with this now, because we're doing it that way. Okay, and we also want this to be there. There we go. Okay. So we have a remove. This remove will fly off in 2 situations. Well, no, just 1 situation. We need it to go off in the 2nd situation as well. Basically when this intensity is 0. So instead of doing that, how about we do this? Ah. Oh, this is in the wrong area. Handle decay. What the heck? Identify. Oh, oh shoot, we can't do that. Yeah, I think it's doing that automatically. It's already efficient enough, right? Yeah. You can't remove inside because reasons. We're parsing that array. So you can't just remove something while you're going through that array. So we just do it outside of it. Okay, I think we're good now. Is there anything that we need to hook into the actual parent of this node? Yes, increase aggro. Yeah, we need to hook in increase aggro to when this thing takes damage. There we go. So we just need to call this. So now this is the part where this is where timing can become an issue. It's very easy to just run headfirst into this. Like right now, it's just about to dive face first right into, oh, guess what? This doesn't exist yet, right? The event bus. Even though the event bus is made on ready, this, because it's a child of the thing that we care about, isn't ready, or is going to be ready before the parent actually has this information for me. So what we will do is in AI free flow, let's just check. Oh yeah, we did. We made that. It is called initialize. Oh, underscore initialize. Gotcha. No, I did that. Init, whatever. Wait, we already have the actor, right? Yeah, we do. There we go. Now we can do let's get rid of this. No, we're looking for the actor. Okay. So, because by the time this is ready, it'll have all of the stuff that this is going to need for it to actually work. Alright, so you just have to remember, in my case, I mean, maybe there is a better way of handling this, but in my case, this is what I usually have to do to get the timing down properly. So in the initialize, then, oh yeah, we have to do this also. Super state. Right, this will make it actually switch out from this state into idle. If you recall, I did that over here. All right. So now, now that we have the AI in idle, right, and we gave the AI the ability to detect the player, let's go back to this where we were before. Let's give the AI the ability to patrol. So the idea is that the AI is going to do absolutely nothing, and then at some random point, well, no. Let's think about this. Let's give patrol a cooldown, right? But before we do that, actually, let's take a look. Let me see what the setup looks like again. This is the prototype area. Enemy, there we go. Let's move this over here. Can we move it? Yeah. Okay. So, yeah, navigation agent 3D is right here, so it's childed to the actor. So let's actually let's stop for a second. Navigation agent being a child of the dungeon actor means that the dungeon actor wants to tell the AI free flow when so free flow combat doesn't need to care about how you're moving around, it just cares about what exactly. It cares about what you do when you're engaged. Right? But it wants to sense if there's things to engage with, and then it wants to handle engagements. So things like patrolling, being idle, those would fall under the actor itself, the AI actor. Right? The sensor and the AI free flow really are just there to take care of tracking what potential targets are around you, and then communicating that to the enemy manager / combat manager if you're the player. Okay. All right. So we need to divorce these two concepts from in my brain first. I think this is where my brain was getting stuck for like the last couple of days. Trying to understand what are the ramifications of splitting things up in this way. All right, let's look at what we have. We initialize this. And this is automatically called from ready. So we don't need to worry about setting anything else up here. We pass in the actor. The question is, do we have the actor already at this point? Let's check. No, we don't. When do we get the actor? Oh, it's exported, so we do. Okay, so we start off with the actor, so we do have it by this point. Nice, nice, very nice. Okay. And then we also have the get things in range. We just need the ability to set that range, the detector shape range, to be exposed to us. Let's see. I think that we just kept the range at a static number previously, because we were just building out. But for the AI, yeah, I think we're just going to use a static. We're going to expose something, but we're just going to keep it static for now. All right. So, oh, oops. Okay. Yeah, it's just Godot. This is all temporary. That range thing. But that is going to be over here, where now we go and say sensor detector shape. Is it the radius? Is that what it's called? Shape. Okay. Shape. It should be like a, there it is, radius. Okay, so when we initialize, we set the detection range. Is that a good thing? I think we should do that over here. Because, like, if you blind the enemy and things like that, you know? Let me just make sure of something. Okay. Okay. So now the next thing that we need to say is we have the ability to detect our targets. So what do we do when we're idle? So for this, I think we probably, the AI free flow probably wouldn't be doing anything when idle. Should we be detecting things when we're in idle is the question. All right, this is where we stopped a second ago. Let's do that. Okay. So the idea is you've entered into this thing's range, and so now it's going to change its state to searching, I guess? I don't think so, right? I mean, just because you entered into its range doesn't mean it's automatically going to start searching around. What would make it start searching? Let's check those different statuses again. Status, but... So we only have engage and disengage. Oh, but this is if we get the target. So that's what we're about to do. We're about to actually check to see if we can see the target first. Gotcha. Search is fine. So now let's try to get the target. And we're going to shoot, I guess, a beam. If you want to call it that. We're going to shoot a ray at the target. Right? And that ray is going to see if it's going to basically go from us to the target, and it's going to see if we actually have something obscuring us from seeing the target. Maybe I'm making this too complicated. Let's stop and think. This kind of game, there's not really that much stealth. That I'm not building it for stealth. Right? It's basically a run-in, beat 'em up, and then get the stuff. So we don't need to worry about stuff like that. What we want to see is if we can detect the target. So we know that the target is in range. So now we want to check with that target and then see, or check with those targets and see if we can engage them. So let's actually do that. I get what needs to be done now. I feel like that already exists in a different form on this. I'm not sure. Wait, what? Oh, I'm looking at the wrong thing. Whoops. So we're over here. And we want to, every frame, check. Oh, hold on. Yeah, we could actually do it from here. We don't need to do that. I knew I had something like this. I was like, I'm pretty sure I have something like that in Dungeon Actor. Whoops. Wait, what am I? Where am I? I should be in... No, this is... bad. Gotcha. There we go. This is where I should have been. Is valid target. Here we go. So there might be like down the road effects that there might be down the road effects that, for example, we might want to have something that obfuscates the character from view, right? Like like invisibility, things like that. So we have that in our effects section, if I remember correctly, under the entity. Right, if we have an effect for obfuscation, then that's it. Go over here. I don't like that. Now, if I remember correctly, I think effects have tags on them. Let's check. What is it named? Do we not store the effect? The actual effect? Ah, we never did. Effect name. Well, how do we do this? This is very old code, so give me a second. Add effect. Okay, so we do it through a create. Data. That's not good. So let's just do this. I don't know what was going through my head why I avoided doing that. Okay, let's update the saving loading. Just making sure things would work. Okay. Okay, let's go back here. Okay, good. Now what? Could not resolve member create. Okay. Okay, good. So now let's go back to the enemy. Let's just do that. Okay, so if there's an effect that's active and that effect has an invisible tag to it, then wait, what? But if the enemy is not an enemy dungeon actor, then this is true. And if the enemy does not have an effect with the invisible tag in it, then this result is true. And so it's a valid target, and we can continue with it. This will allow it now to do that. So we could actually, since this is this gets complicated. What if we can see invisible characters on this enemy, right? I mean, we already finished the groundwork of just checking for has effect. That's not difficult to put in, but... Oh, whoops. Actor. I think we have to split it up, make it easier. So the result is false first, and then we say, well, if the actor is not another enemy, then result is going to be equal to true. However, if the entity has the effect invisible, I think that's how you spell it. One sec. Yep, that's how you spell it. Okay. So if the actor is invisible and the entity effect has the effect clairvoyance, I think there's a better way to handle this. No, this is it. So the result is true right now, but if the enemy is invisible and we don't have clairvoyance, then the result becomes false. All right, and then we pass that through. We also have the case of if actor I think that's what I want to have done. Yeah, I think this is fine. Now the next trick is to just do that. That way we're not running through everything. And we can actually do this first before we go into the other one. So we check if the actor is a dungeon actor, and we just return false. Alright, we don't attack other enemy actors. Later on, we're probably going to have like factions. So this is probably going to be replaced with if this... Like, I already have factions, I believe. Hold on. Yeah, faction manager. The faction manager already exists. It's just I haven't registered these enemies with factions. I could have sworn... Wait, faction manager should have a ton of stuff going on. Why is it... Yeah, it does. Ah. Weird. Okay. Alright, let's get back to it. So this is going to check for us if this is a valid target. We can just... This is much cleaner. We can just figure this mess out, lay it down the road. Right now, this is fine. Let's get back to the enemy itself again. Where is it? Yeah. Oh no. So... Okay, that's fine. So for the next trick, we want it to handle idling and patrolling. Let's look at dungeon actor, state machine options. Initialize neutral combat attacking. Disable. Okay. So we can assume that we're coming out of a neutralize into idle by default. So once we're in, let's take a look and see what we did before. We don't need to use this anymore because this is taking care of this stuff. But we do need this. So this is what I mean. Like, I wanted to take this out and turn it into a separate node, I think, instead of doing everything inside of this. Because it turns into a very long script if I do that. But instead of doing it through nodes, I was debating if I could do it in the form of a... there's three options. I could either make it a script, I could make it a node, or I could make it a resource. I think the least valid option is a resource. Or maybe it's the most valid. I think a resource is a good option. I'm going to try doing a resource first and see what happens. So we're going to call these behaviors. These are resources, so they don't need to be here. AI behaviors. Okay. Okay, so now let's save this. We're gonna make a new script. We're gonna call this idle behavior. And we're gonna call this patrol behavior. And I think we're gonna leave it at that for now. I don't want to, and maybe even combat behavior. Right, these are things that yeah. Do we need a manager for this? I don't think so. Maybe, I don't know. So let's go into idle behavior first. And we're going to export Okay, so basically the idle time is how long this behavior normally runs, and then the idle time bounding will be the variance. right? So basically, we need to put up okay. So we don't need to basically we don't want to go too deep into this. I don't want to recreate a state machine. So the idea here is simply um when we start the idle behavior, we want to tell this dungeon actor things that it should be doing, right? So we're actually going to take this, go back up to behaviors, and then do that. Okay. So now we so now we need aha, okay, gotcha. So let's actually go here real quick. Why isn't it fixing itself? There you go. Okay. Next we go here. We create behavior. I think we're getting the best of both worlds here, huh? Yeah, there we go. Okay. So over here in behavior data, we're going to go with func. I've heard of this. This is the mythical, this is the mythical bloated node tree. All right, so let's do some organizing before we do this. No. You know what? You know what? No. Negative. We can fix this problem just by making this ref counted instead. Alright, that way my scene tree doesn't go completely bonked. What? What's going on here? Create. So now, programmatically, what I want to do is or rather, we want to be able to drag and drop in the behaviors that we need to have handled. Right? And when we do that, these behaviors need to assign themselves properly. So we can just easily call them. We have a combination of things that are required here. Let's start from the end and then work our way back. I think that's the way that I need to do this. What's wrong with behavior data? Come on. Okay, there we go. I'm like, what the heck? Okay, so we now need to, once we set the entity, initialize behaviors. Yeah, it's much easier when you start from the end and then work your way back. For I in behavior data. Yeah, actor should be a thing, no? What am I in? I'm in enemy dungeon. Oh, self. Okay. Fair. All right. So now that this is set up, now we can go to here and we can just make a func create actor. It'll return behavior and it will say turn null here. Okay. Okay. So need to update the other one also. What was it? Idle? Okay, good. So this should help keep this, like when I was testing things out, this is how long this script ended up becoming. It was becoming gigantic. So what this does now is that it breaks it apart to just being the types of behaviors that I need it to be when I need it to be it. Right? And this script is really just more about navigating to those different behaviors. Maybe later I can add something in there to make it also check for behaviors that I might want to add at runtime. All right, and then we can just replace that behavior inside of our behaviors dictionary over here. It's a lot easier when you start from that side coming back. Okay. Give me 1 second. I'll be right back. Sorry about that. Family, things like that. Okay. So we initialize the behaviors. We did this. We create self. Behavior. And then it adds itself to the dictionary of behaviors. Good. You know what? I want to try something else. This is new. Why not? Okay, there. I think we can just continue to populate behavior as we expand the various behavior datas. Worst case scenario, we might have to just create a, have to do something like this. There we go. Dictionaries. Like the Swiss Army knife of GD script. Okay, we're good here. So now that we have the basis for this, let's go back down to our idle. Where is it? Our idle behavior. So when we start the behavior, we're going to assume that first the actor already changed its state to idle. So once it does that, it's going to ping this saying, hey, whatever the idle behavior is, start that. So we're going to get start behavior. It's going to pass in the behavior information of whatever we need. Right now, though, for idle, what I want is for it to check against the idle time. And once it's done with the idle time, it will attempt to exit the idle state and then go back to the behavior state. All right, so we're actually just going to go like this, behavior. Yeah, just keep it simple. Behavior run, right? Let's just think about this for a second. We just changed into the idle state. We want to stay in idle state for a while. Is the idea. Right, okay. So we just tell the behavior to run, and then when we run the behavior, if the behavior dot properties, I already forgot the name of it. Start time. If the behavior properties start time is minus hold on, which one is the less? Start time is the less. So if it's actually time dot get ticks. Okay, so as a baseline, so now we can extend off of this, basically just inherit idle behavior, run super on this, and we can do other things in the inherited class for run behavior. But it'll always just do this and it'll kick itself out of running the behavior, and then we go to exit behavior. So now the exit behavior, in this case, I think we want to check, we want to try to go into patrol if we're not idling, right? So patrol just basically means we walk around and do stuff and then we idle again. So in this case, I think what we want to do is it passes itself. Okay, you now again, a keen eye might have noticed we never made this. That's fine. We can go back up to behavior real quick, and we'll instead have this return behavior. Behavior exit signal. Okay. This is doing quite a few things, but basically now we have a way of tracking if the behavior has stopped using events or signals. Yeah. Okay, we're good here. Okay, this is fine. So now we have a way of transitioning through idles. Right? And when we go here, we can adjust the different idles. Let's actually... Oh, whoops. Just do this. Oh, I see what I was trying to do. Okay, I see what I was trying to do there. Like, what the heck was I going after? Basically, we're just trying to add in some variance there. So... Yeah, let's get rid of this. There has to be a different layer. No. Yeah, I get you. I know what we need to do. Let's go back a couple steps. Okay. Am I using that for anything else? No, we're not. Okay, good. But I get worried. While loops are sometimes scary. But yeah, so now this should work entirely independently of the process, which can be a good and a bad thing. Okay, so now we can slow this down a bit. Let's go. So instead of updating the AI every frame, we're just going to be updating the AI's behavior every third frame. And there we go. Okay. Okay, so now we hit stop. And then once we stop, we will handle the exit behavior. Exit behavior. I mean, I think we can get away with just doing behavior exited.emit. And I don't think we need to do this. Instead, we can do this here. Right, so when we start, we can always just do dot behavior exited. Okay, and then when we await the behavior exit, then we can go, let's say, into patrolling. There. So let's look at behavior data. Where is it? Idle behavior. Okay. Exit. So I think we can leave this as pass. And then we can put this here. What? Oh. Run. Start, run, stop. Parameter event is called but never used. This is old, I think. Clear. Okay. All right, let's go back to the dungeon actor. So we go through this and we initialize the behaviors. Now we have our state machine here. So now when we are going into func, let's just inherit idle. That should pass. What's going on? Dungeon actor. Oh, it's neutral. Neutral, combat, and attacking. Gotcha. Good. There we go. Oh no, we don't need to do that. We need to implement that also. Hold on. You have to make tool. You have to put that on all of them. There we go. Okay. So what is it? Behavior data. So that will start the idle behavior. Okay, so when we enter the neutral state, we go idle. Then we await for behavior exited. We need to do a check. If it's not in the same state when it comes out, then we just return. Okay, that's what I thought. And then we return when we're not in the current same state, and we it's like if we're over here waiting for the behavior to exit, but sorry, we oh, no, I can't think of a way to handle that. Maybe like an additional listener. But there's no way to cancel a coroutine. I think you can't. I don't think. Yeah, Godot. I don't think Godot has stop coroutine. We'd have to get a little bit fancy. All right, let's go back to behavior. What the heck? Oh, there we go. Feels like something is missing. So let's ask. No. I think, yeah, let's just get rid of this part then. Ah. Oh, come on. There we go. So now it will listen for interruptions. And if you interrupt it, it will stop this state. All right, and that only happens after the state machine changes the state. And then if we go back to this, we can check if the current state is the same state. In other words, it shouldn't be if we've been jettisoned out of this. If this came out, behavior exited, happened early for interruption reasons, this should already be changed. And so we should just return. Otherwise, we're going to go into change. Oops, state machine. Change state. What am I doing? What the heck? How did I set it up before? Oh, okay. I used the Boolean for it. I didn't change the state. Should I make it an actual state, or should I just use a Boolean and... Yeah, I think we should leave it and just use a Boolean. Okay. Is patrolling equal to true? Okay, so now if it is patrolling, it's still going to move, because the reason why I didn't want to make a new state for this is, I mean, we could do it fairly easily. It's just that the changes are just not significant enough, considering that we have like a subsystem right now that's going to be handling those changes independently of other systems, right? Like, once we're into the next behavior, we don't care about anything that's happening in idle behavior anymore, which is the point of a state machine. So this is kind of like a mini state machine for AI specifically. But the overarching state machine for this actor I don't feel the need to expand on it too much, because that can start getting a little bit in the weeds and you have way too many states. No matter how genius level your intellect is. 11th level. Let's see. So is patrolling is now true. We're still in a neutral state, so all the other parameters of movement are maintained. And then we say we want to... since we're not actually changing the state, we're still in neutral, we can go and do that again for I in behaviors, values. Oh, music stop. Sec. Oh, no. Okay, let's see. For I in behaviors. So if I data is troll behavior, we haven't made this yet. A keen eye would have noticed that. Found, it's the same pattern. I is going to be equal to I and then I and then we break. And then we do await found dot start self behavior exited. Okay, this one's a little bit different, right? This is just going to be how we handle letting the AI patrol around and stuff like that. So for this, I like to have this. Or actually, let's call it this, patrol point. Right. Okay, so let's make the patrol behavior. I'm pretty sure you're seeing where I'm going with all of this stuff now. So let's grab idle behavior real quick. Okay, patrol is a little bit different because we're going to be relying on a method that's going to be inside of the actor heavily. So let's do this. I really don't like how this is. So this is like a slider, but the moment that you make this an integer, it just doesn't work as a slider anymore. I think that's a bug. It has to be, right? So let's get rid of that for now. It's different now. Ah, wait, what? So we can do something like this. Oh, whoops. So basically, we're going to start this, and then we're going to just set the properties for the current points to 0. And as the object moves around, we're going to use the agent to send a message to the actor whenever the agent has reached the end of a patrol point. And essentially what's going to happen is it's going to say, okay, you've reached the end of this patrol point. You can make up your mind on what to do next, right? So once we reach the end of a patrol point in run behavior, that's going to be that's going to be like I think that's going to be something that we want to put in, right? Like basically maybe we want to stop and idle for a bit and then move on. But as a baseline, I'm going to make it so that way you just keep going until we patrol through all the points and then we go back to idle. But I think I want it so that way it will just pick, at random points, it might just pick this point to go idle at. Right? I think that's a good... Okay, gotcha. Alright, so let's go back up to Dungeon Actor, and let's divorce some things out. I can't call it divorcing, but it is what it is. Let's save that so that way this stops bugging. And we're gonna do this. Func. Okay. So now you go here and do Oh, it's already there. Okay. Okay, so this is where we start getting really dynamic with it, right? We're going to make it so that way when we start patrolling, we can go back and then have like moments where we're idling, and then we're going to start patrolling again. And it's just random. Like we can patrol through 2 points, and then we go back into idle, and so on and so forth. But this all begins when we enter the neutral state, right? So technically it's still patrolling. It's not going to change from patrolling until we get through behavior exiting. Right? Once we get there, then patrolling is over. Sure. But between there and what's happening in here is going to be, basically it's going to come back up and then say, hey, I want you to do start idling, and so on and so forth. That's basically what is going to happen. Yeah. So we need to get a little bit fancy in patrol behavior, the way that it starts. Okay, and we need to just randomly select, I guess, a couple of points. So like let's say we have 5 points in patrol, then we need to just randomly get a couple. Let's say I mean, the alternative is that we could just let's just make this super simple, right? And just have it loop on itself. But I kind of like the idea of it, because if we just make it loop, I guess we could put something there that will say like, should, like make it like a random chance for it to check for if it's going to idle or if it's just going to go straight into. Yeah, we could do that. That's easier. Right, that's easier. So let's go back up to here real quick, and it'll be done right here. So we'll actually do something like this. If should idle. Right, so we do like that. If should idle, then we will await for start idling to finish, which is going to be when the behavior exits for that. Then we check to see if our state changed for any reason. If we did, then we just return out of it because we're not going to start patrolling at that point. And then when we start patrolling, we are building that now. So it'll go through the dictionary of behaviors, try to find a patrol behavior. If it finds one, then it will do that. Let's actually do this here. Forgot. Okay. Yeah, I think this is the better bet. Let's go here. Right. So you have a 50% chance of just going idle. This is misleading. Let's rename this. Should do transition. Transition. There we go. Okay. There. So now it's actually going to just keep doing it now. So first we check if we should transition to idling. And if we do, then we await idling to finish. Then we check if the state machine is still in the current state that is neutral. If it is, then we move on to patrolling. And then again, we check if we're still in this state. And if we are, then we just repeat this cycle. And this begins once we go here. Right? So now the thing is that this is an infinite loop unless the state is changed. So once the state change happens, it should just boot us out. This walking the fine line. But it's nice. It plays nice, right? Well, let's see if it plays nice. So start patrolling. Okay, so now we have the patrol behavior, which we've just simplified patrol behavior a ton. So patrol behavior wants to tell us a couple of things. First, it wants to tell us the amount of patrol points that we're going to have to negotiate. Right? I think that we don't care about that, actually. So this is gone. Right? We don't care about that. And actually, I don't think we need to, actually, I don't think we need to execute run on this. Or do we? No, we do. Because we need to get the... Oh no. Oh no. Gosh. Irk. This is crazy. Oh, Delta. It's not too big of a deal, right? I mean, it's an easy fix. Let's go back up to behavior. Okay. Okay, good. Yeah, it wasn't too bad. Yeah, so basically, because I'm using rigid body, I want to make sure that this is not operating outside of a physics frame. So we're going to negotiate the movement of the character on run behavior. It just crossed my mind to just handle it here. So that means that this needs to actually be accurate. Behavior.run actor. Okay, so that means also we need to do behavior. Doesn't matter what I put in here, because I'm not actually checking for the value. I'm just checking to see if this actually has it. It gets more tricky if I'm going to check that. Right. So then we can run this. So now when we run this, we have our out here, which is... So we don't care about the patrol points. What we care about is when we reach the end. Right. So let's get the agent. Wow, what's your problem? Oh, right. So we actually have this made already. Let's just go grab it. Where is it? There we go. Okay. That's not what I named it, right? What did I name it? Patrol point. Okay. Okay. So once we set the destination, I believe we need to call something each frame for this to work.
should be at close to the bottom, I think. Yeah, I was doing just a whole bunch of stuff, just testing. Huh. I could have sworn there was something that you needed to call every frame. Oh, we do that already. Huh. So we didn't actually have to worry about this run. Because the floating capsule's already handling calling the movement script inside of itself. It's basically, once we set the destination here, remember that input control behavior that I showed a while ago? That is basically called from inside of the physics process anyway. So we don't actually need to do this part. So what we need to do here is we need to create a listener for when we reach our destination. So if actor agent, hold on. So actually, let's bring that back a second. There we go. Just making it easier myself. And maybe we don't need to run this at all, because it has the signal in it. Let's just put pass here for now. Hold on. There we go. So here we await, and then once we do that, then we go behavior. Stop. Actor. Right, because the actual floating capsule is already handling. The moment that we do this, the floating capsule will kick in. And we'll attempt to move the agent to that position. If that makes sense. So we should just be able to do this. Let me just make sure that I named it agent. Yes, okay. That's the thing with dynamically typed. You don't know what the heck is at the other end. I try to statically type everything, but, you know. So we never actually run most of this. we're going to run stop, but I'm trying to think, what do we need in stop? I don't think we need anything. All right, we just start the behavior here. It's going to pick some random positions for it to move to, and then it'll go to that position. And then that's it, I think. And it should just cycle through it. We're not going to make the combat yet. I'm just going to test this out to see if it's working. But before we can do that, we need to actually give it these behaviors. And before we do that, well, no, we can just do this, add element. Give it a new idle behavior, control behavior. And the idle behavior will set the, oh, what the heck? Not letting me, why can't I change? It's like going, what the heck? Okay, I don't know what the heck is going on there. But let's check idle real quick. I don't know what the heck is going on there. Idle behavior. Are we doing something weird here? Yes, we are. Yeah, but this is the getter. Are you serious? It runs the getter. Okay. Did I make it too small? Oh, whoops. There we go. That gives me an idea. About how to get that to work, though. Just having it as one. So let me get this straight now. Basically, if the bounding is 0, then it's... Oh no. Okay, hold on. There we go. Yeah, so if this is 0, then nothing really changes. If it's a negative... I think we should just stop at 0. I don't think we should go to -1. -0. I think that's it. And I think because we minimize it, we can go up to 2. So basically, if we go, let's click off. There we go. Yep, there we go. Okay. So if we go up to 2, we go 0.5 of 2, that'll be 1. And if we go down to 1 second here, so let's actually just make this 0.25 as the lowest bounding. Okay, good. We're going to keep it 0 for now, and we're going to set the idle time to, let's say, something 6.5 seconds. And... oh boy. Crashes and shenanigans. Ahoy, I guess. I don't know what the heck is... oh, the visuals folder. Okay. I think we're ready to test this. Let me just read this one more time. I always mess up here. I know I made a mistake here again too. So basically, the current time, let's say this is 1000, and the time that we had started, let's say it's 500. So if the time between here and here is greater than the idle time is that times 1000. Since these are ticks in milliseconds, it's basically 1000 times whatever number you were probably thinking. That's the reason for that. And then we multiply it by the idle time, idle bounding. We don't need to do that though. Should we? I don't like the idea of adjusting the start time this way, but it makes sense. We don't need this. Just at once. You know what? I don't like it. Behavior, properties, active time. Okay, there we go. And then over here, we can just do active time. All right, and then we run. And so the active time plus whatever the bounding is greater than the idle time. No, wait. Yeah, it's greater than idle time. Wait, what? Okay, so if this goes way too far out, and this is stretched out, then it's greater than the idle time. In which case, then, it will then execute behavior stop. And then let's take a look at the patrol one more time. Patrol is pretty simple. It's just going to execute this. It'll find a random patrol point within 15. And it'll just go around that patrol point. Like that. And then it can execute behavior stop there. When it executes behavior stop, let's go back up in behaviors. So we kind of skip this. We don't actually use this on patrol. And this is again because we just have that floating capsule system slash input system that's already tied in to our agent. I think. Should still be tied into the agent. I don't know. Yeah, it is. The floating capsule is handling it. Should the behavior handle that, or should floating capsule handle that? Floating capsule has to handle it, right? Because that's where it's being called from. Like, all this is doing is just sending the information, like, hey, this is supposed to be your destination. The floating capsule is then just saying, hey, what's the current destination? And moving to that destination. So yeah. This is like giving, the other one is taking. Okay. And so we come to the stop, and then that's that. All right, so I feel like a pro, bro. I'm gonna just run this and know that it's going to crash and be content. There, crashed. Okay. Right away it just crashed. So yeah, we didn't actually make this because we turned out we didn't need it. Where are we? We're in AI free flow. Right, so let's get rid of this for now. Let's just do this. For right now. We don't need that. Okay. This is for something else. Okay. Ah. Yeah, we didn't finish this. So where are we? AI free flow. There's a lot of stuff in AI free flow we just never finished. Let's pass that. Again, AI free flow is basically just there to detect when we're in doing different things. Like, I'm still putting it together, like how these systems should really be organizing themselves up. But oh, what? So it's basically saying that we're doing this before the state machine is actually made. Where are we calling this from? There's a wait call. Ah. Okay, here we go. So we're making the state machine, right? Oh, I see what's happening. Okay, gotcha. Remember what I said before? Let me show the screen. There we go. That should fix that. Infinite recursion. I know there's an infinite recursion. You know what? Let's do it this way. Maybe it won't pick up infinite recursion if I put it behind this. If it does infinite recursion one more time, I'm going to have to check to see what's going on here. Should do transition. What's happening in here, Randy? We'll wait, start patrolling. Yeah, okay. Sorry, I was just reading through the code one more time. It should not. Huh. I know about that. Okay, let's do a quick test. Find out what's going on here. Print A, print B, print C, print. I think it's just saying infinite recursion, not realizing that there are things between it and the possible recursion. What the heck? Okay. All right. Looks like we have a problem. Let's do this first. Okay. Then we're going to go into start idling. So we can assume that we're not finding oh, hold on 1 second. Hold your horses. Idle behavior. Okay. So now let's give that a shot. Why is it giving me... What the heck? Patrol behavior. It's... What's going on? Is there an error in it? Yeah. No, there's nothing. Okay. Something is up with patrol behavior. Idle behavior, working fine. Base idle. Oh! I think it's just because of that thing. I get you. I thought I wrote... Didn't I write in... No, I left it base idle. There we go. Base patrol. There we go. Thank you. Thank you. All right. I forgot when you change so I have it on the setter to change a resource name, so that's what was making this, but I was able to tell the difference because this has a ton more stuff going on. Okay, now let's yeah, okay. I don't think we need to even use a dictionary for it, I'll be honest. Because I had something else in mind. Let's go back and just change that real quick. Because I don't think we need... Oh, we didn't... Yeah, we did. So we can change this to an array. Okay. Behaviors, append, and we can just do this. All right. Let's try it again. Right. So the goal is just to see if it's creating pauses. There we go. Like I should be going to like A, then pause, B. Nope, it goes straight through. A, B, C, straight through. A, B, C, D. Yeah, it doesn't stop for anything, which tells me that something is happening inside of these. So let's find out. So before we do that, do we actually initialize the behaviors or no? I don't think we initialize behaviors. I think that's the problem. Yep, we don't. Okay. So where should we initialize it? Probably in set entity? Yeah, no, we can do it further up. They're not dependent on anything happening in the class, I think. Like, they're not trying to get information. Nah, yeah, so I'm going to set it all the way up here in the top of set entity. Save. And... okay. Now that should work. It was just breezing through it because there were no behaviors initialized. Okay, there we go. It still breezed through stuff for a bunch of them. Okay. All right. Now let's get this done and out. Just needed to get it to not crash first. So now the next step is we check through idle and see if this is... Huh. Actually, let's do that. Okay. We should get a ton of A. And yep, tons of A. No B's. Why? 4I in behaviors. Oh. What? If not, I has. That's why I made it a dictionary. Okay, we don't need to worry about that because we're only ever doing this once. Right, this is like the first thing that's done, so we don't have to worry about it. This is an array also. Yeah. Okay, let's try it now. Actually, hold on. I want to get more information out of this, so let's put this back to the way it was. All the sizes should be 2. I don't know, that it should have been working. I mean, granted, I'm happy that I spotted that, but it should have been working. I'm not sure why it didn't work a second ago. Yeah, it's reading zeros, saying that nothing is in them. Why is it saying nothing is in them? Dungeon actor. Enemy. It's right here. Oh. No. We're right. Because we applied the Cinti visual first. Oh yeah, you know what? You know what? Let's do this. Tools. Okay. Excellent. Okay. Let's reload this script. Everything is fine. Okay. So now we go here. There we go. Enemy, where are you? Initialize behaviors. Let's just get this out of here for now. Idle. What the heck? Where is it? Where the heck is it? Is it not loaded? Where the heck is behavior data? I might need to restart Godot. When this type of thing happens, that's usually what it means. Let's try that one more time. It's inside of resources, AI behaviors. Let's actually just do a check. Yeah, it's not even in the list. Let's try it one more time. Up. It's out of here for now. We got a ton of warnings. What is this about? Oh, it's the same thing. Clear. I'm gonna do that one more time just in case, though. Alright, we got no warnings. So let's... Okay, good. Let's close it again. Update. And discard. And we have nothing for behavior, right? You know what? We'll do it live, right? This is sad. Why isn't that not picking it up? Okay, let's check the property generator. We got a bunch of warnings about stuff. Enemy dungeon actor could not parse. I don't know what that's about. Yeah, it's not picking it up at all. Not even on the it's not even picking it up on the just general list. That usually means Godot needs to be restarted. Something must have bugged out somewhere. Because all I'm doing is sampling the entire project and saying, hey, and no, it's right. Because all I have in here is script. This arrow was misleading me. I'm gonna blame the arrow. So we need to do a use script resource. Idle behavior. Control. Okay. Okay, now let's update this. Yep, there we go. But it's screwed up, so yeah. It's putting it under world time for some reason. I never figured out why it does that. It just does it randomly. It should not be under world time. It should be under behaviors. Usually, like I said, this is like a you need to restart Godot kind of situation. So give me 1 second. My guess is that it doesn't have certain things set up on its metadata. And so it's just giving me back whatever it can, and it always is world time. What the heck is this now? I have no clue. I did not change so many things that you're just going to go completely off the wall, are you? Enemy dungeon actor could not... Oh yeah, okay, that's fine. I know what these are. We just have stuff incomplete in this class. It's absolutely fine. We're not messing with that. Okay, let's try doing this again. Life bar port. I have no clue what that is about. Paths node is invalid. Sure. Let's try it. Properties. That's the old one. Close. There we go. Okay. So now let's get this done. Okay, so we did that for a reason. Okay. Now, no one can say that you do not have these two classes. But now let's try it. Oh, wrong thing. Oh, wait. I think there was something that needed to be done, no? I guess not. Must have yeah, I don't know. I thought I left something incomplete. Sure. What the heck? The only thing I could think of is that that's being called from somewhere else. This is the weirdest thing. It's just a matter of testing if this is called. Let's see, print. Okay, so it's calling the behavior. Oh, I see. That's getting called before the behavior actually gets set. It is setting the behavior. It's just doing it. I gotcha. I gotcha. I got you, little buddy. So the question is, when is this getting called? Handle neutral. Being called on neutral. But we do call deferred. I see, I see. So we actually don't want to do this here. We want to do this in initialize, which I believe is its own state also. Yeah, it's right here. So we can actually just get rid of this here. We got you, buddy. Who knows when that's being called, but this one we know for a fact initialize is being called before neutral. Okay. Haha, we made it further. Gotcha. Okay. Ooh, that's good. That's good. Okay. That is excellent. That's exactly where I wanted to crash. So let's go back to behavior data. Okay. You forgot we never created this. Haha. All right. Okay. So now we should play through. What the heck? Invalid access type key data. In English, please. Invalid access to property or key data on base object of type nil. What? It's saying that I doesn't exist. But did I inherit? I thought, let me just check. I might have inherited behavior data. Where is it? What was it again? It was idle and something else. Idle behavior. Yeah, that's what it is. I'll be right back. Sorry about that. Yeah, let me check the other one also. Yep, okay. Hey, they're doing stuff. They're only going to do it once? Huh, they're doing all kinds of weird stuff. I have no clue what the heck is going on here. Oh, remember that thing at the very beginning that I deleted from that other thing? Where's AI direction controller? Yeah. I'm trying to remember what that code was. I think it was something like if it's supposed to return 0. I'm trying to remember what the code was here. I don't need to remember. I recorded this whole thing. One sec. It was at the beginning, right? That doesn't look too bad. That was when I was working on the combat manager. I can't remember if it was before I worked on the combat manager or after. Oh, here it is. I just saw it a second ago. Enemies, circle data, set destination. So it should be around here where I was messing with the... There it is. Okay. Looks like I already removed it. It is... One sec. This is at 4 minutes, 4 hours and 51. Okay. There we go. Found it. Okay. Just before I deleted it. So it's if entity.is navigation finished. Ah, there we go. Is navigation finished? Entity current target. Okay. Let's try it. I think this is it. Oh, wait. Is navigation finished? Yeah. Just making sure I spelt it correctly. One of them is attempting to move, it looks like. It isn't moving. Okay, let's just put something here and see what's happening. Print moving. Okay, it's not moving, or it's not being called. Huh. What did I forget? What did I forget? We have super date here. Is there anything else? That entity is a valid target. Let's get rid of this for now. All right, let's see how far we get in. We should be getting pretty far because it's actually attempting to create a path. Right, we're seeing that red line, which means that it's getting to where we're setting the destination. So let's do initial patrol behavior. Okay, and idle behavior. Okay, let's try this now. Making this system from the ground up is Interesting. A whole bunch of them are doing patrol started. Okay. All right, let's go and do this. See if we get infinite recursion again still. Okay, so it is detecting it. It's just not applying forces. It should apply forces right off the bat, though. That's a little bit confusing. The reason why some of them are doing it and some aren't, though, is because of this chance that we have down here. I'm confused. I don't get it. What the heck is going on here? We have behaviors. Okay, well, we're not doing infinite recursion anymore, which is nice. What do we need to check for? Alright, let's go back up. Dungeon actor. So this is where all of this stuff should be happening, right? So neutral. We did this. This is so bizarre. What is going on here? Neutral. But it's not calling. I see. It's not calling it. It's not calling it. That probably means it lost it. Hold on. No, it's right here. AI direction. Free flow combat. It's all here. Okay. Let's check the floating capsule, I guess. where's neutral moving pack? There we go. And then the get direction input methods. Now I can't just put a break there and test it out because the player uses that also. So it would stop me right away just because the player got through. But okay, so it's saying that the enemy was at what the heck? That's called every frame? Oh yeah, it is. The neutral movement pack is applying forces, so it is doing get direction. According to this, it should be doing get direction. And AI direction controller. So if it's calling get direction, let's just check here. Print. Clear this. Okay, so we're getting somewhere. So it is calling this. But we're not getting past this. We're just returning vector 3.0. Why? I knew that there was something that I'm supposed to call every frame. I think this was it though. Let's do print dir on this. Yeah, no, it's getting called every frame. Hold on. Yeah, no, this is the AI. So we are doing this. Print entity global position. And interesting. Huh. Let's check the set destination script. What the heck? Where are you? Set destination. Oh, found you. Okay. Picked a random spot and then we set this as a destination. and then we check a path. We just tested this a second ago and it worked, right? All I did was copy paste a bunch of stuff around. So it's saying over here. Now it would only say this normally if... So let's actually do this. Okay. This is more sense. So the area that we're trying to get to is different than the area that we're in. But for whatever reason, it's not applying forces in the direction to get us there. Interesting. So it's reading... Let's just... come on. Why is it doing that? Stop. There we go. Okay. Okay. So then obviously the navigation is not finished because we need to navigate. So let's do a quick test. Okay, gotcha. It was just that. Now they should be moving around. Right? I guess. Well, let's test this. Theory print.
So if this is false, which it's false now, so the navigation is not finished. So wait, if entity navigation is finished, right, then it should return vector 3.0. Okay. And then so wait, does that mean that there is a current target? Gosh, I was hoping that. I don't think I hooked that in. I don't know. Entity current. Okay. Make this and. There we go. So they shouldn't be waiting this long to move again. I don't know what's going on, but they shouldn't be waiting this long. That's crazy. So it's true. This is true, and this is true. So they're both reading true is the issue here. Gotcha. So the issue isn't here. The issue is now back where it belongs in the behavior. Okay. We're getting there. So now let's go back to, yeah, it was just this. So apparently this line existed for a reason. Basically, so what the problem is that if you just let it go straight to this, it'll create that jittering effect where sometimes you'll see those characters bouncing all over the place and whatnot. So you have to have something like this to tell it, hey, yeah, just stay at vector 3.0. And the good thing is that the floating capsule, when it receives a vector 3.0, doesn't do much, so it's very efficient. It's not like producing any forces. It just basically just says, oh, okay, yeah, let's return back, and then it only handles the physics related to keeping the object standing up and things like that. So, yeah, something is happening here. Let's clear all of this. So let's get back to this part.
how it always starts there. It's completely random. I don't know why it does that. Maybe just coincidence. Should be. None of them are even trying to. Yeah, okay. I don't know why it's not moving. I don't know why. What did we make a mistake with? Waiting. It shouldn't be this long. It's only like 6 seconds, right? So it must be that, remember that part that I said I always make mistakes on? It has to be there. So let's go to it. Like, I always screw up the math there. Oh, oops, what did I just do? I think I just closed Godot. Did I? Oh no, okay. Okay, we don't care about this right now, so let's do that. Okay. Yeah. Enter. That is a long time. Holy cow. That's probably what the problem is. Is it? I mean, that's 30 seconds in. Are we 30 seconds? Yeah, we are 30 seconds into the game. Okay, so understanding what this, where is it? Understanding what this number is now. The question is... Question is, what is idle time? Actually. Alright, let's get out of here. Let's try that again. Weird, weird, just weird. Okay. So let's go back up to behavior. I made a mistake somewhere there, I guess. Can I get more information out of that than just running? Maybe, hold on. Running A, running B, and... S. Sure. Some of them, I can't do that there because some of them will be using patrol. And so that function or that property doesn't exist in patrol. Running A. Okay, so the while loop never goes off. We found this is the problem, Houston. What is wrong with this while loop? It's because of this is processing. Let's try that. I've never been able to use that properly. Like I've always tried it and it never works out. Like it does something, it's just not doing what I think it's doing. Every time I read the documentation, I make the conclusion that it's saying basically that the node is in its enabled
state or something to that effect, or the process mode is enabled. But I think, yeah. There we go. Okay, it's running A, It's not running B. Why is that? We set is running to true over here. Oh. There we go. Okay, so maybe, hold on. Oops. There we go. So I did it backwards. All right, let's get out of this. Now let's try it again. Okay. All right, let's get rid of that. Get out of here. Let's try that one more time. Okay, now it's running B. Stopping idle. What the heck? So it did get to stopping idle on one of them. Let's leave Delta alone for a second. And it was running B for a very... Oh, just different ones were stopping idle. Gotcha. Okay. So we now know that this is running and stopping idles. So now we can go back up to the enemy and figure this mess out. So if it says it's stopping idle, what does that mean? It means that it's calling idle. Yeah, it's calling this, and it sets a stop time and exit behave. What? Okay, yeah. So in run, we do this. We stop that behavior. And then from run, let's do it up here. And then we do data.exit behavior.
and behavior exited. Which is working, it stops that. Oh, that's why. Oops. And stop. I think that would fix it. I forgot to put a wait before that. You guys can't see that one. Okay, let's get out of here. Try that again. Actually, hold on. Let me go here. You guys can't see this. But it's a small... You know what? Let me do that after this fails. So it shares the entire thing. Okay, running. They turn and look at the next path. Nobody is in idle. Oh, they started doing idle again. Why is idle time 0? Alright, let's come out of this. So let's make idle time a number. And the idle time bounding so we can get rid of this now. So the bounding is going to be equal to the idle time times whatever. So we don't even need to do this anymore because we can't get a negative number with this. So what happens? At 0, the bounding becomes 0. And then we do -0 times 25. And we set this to the start time, but the start time was never set. Aha, gotcha. Okay, so that's the problem. I'm surprised it didn't give us errors. That's weird. Why didn't it give us an error? Do I already have start time? Yeah, I do. Okay, gotcha. There we go. Just have to have patience with Godot sometimes. Okay. We don't set the start time here. Actually, it's supposed to get set up here, if I remember correctly. Yeah, it's the first thing that we do. Start time is going to be equal to... And then we do start behavior. What the heck is going on? Print? What was I looking at before? You know, let's get that number one more time. a little bit confused about that number. Print. Active time. A little confused by this number. My motto is do it the wrong way 1,000 times and then get it right. I don't even know if OBS was displaying. Oh well. Okay, get back to it. Oh, oops. There we go. We did it once. And we got a big number. Okay. Let's go back a step. This is a huge number. What is bounding? And then, what is idle time? Right, and we know that start time has values. And what is this? Okay, let's check these three numbers. I think the last one should be 0, but again, you never know. They're all 0. Wait, that's not right. Idle time should not be 8, it should be 8,000. The rage. Bounding is 0, that's fine. This is 0, that's fine. This should be 8,000. But you know what? This didn't work. We're just gonna get rid of all of this. And we're just going to put any references to idle time needs to be multiplied by 1,000. I didn't know that when you do get, In Godot, you automatically also do set. So anytime that I would, from the inspector, I'm not sure if programmatically it's doing that. Well, programmatically it isn't even converting it. It looks like it is because it's so bizarre. Like, you would think if you're doing get, you're not going to be doing your set because you're just, well, it's a getter. But for some reason, it's like calling back to the setter when you call it inside of something, I guess. I don't know. It is so quirky. We don't need to worry about this anymore. Because we now know what idle time is. We have idle time times 1,000, and that's it. So yeah. Now this should work. Then we go to behavior stop. We just put that there. It should be working, but for whatever reason, we're not seeing the result of it working right now. And I guarantee you it's just something that I missed. Oh, found something. Aha, for like a half a second it showed up. But I saw it. Wow, it ended the idle behavior pretty freaking quick. Okay, so instead of poking idle behavior anymore, now it's time to poke at the patrol. Because it looks like we're getting through idle instantaneously, which we shouldn't be. Right? We shouldn't be, I don't think we should be getting through idle that quickly, but it is what it is. Is there a way to check? I think there is. Hold on. Can I just copy paste? Yeah, there it is. Okay. So this is going to tell me exactly how much time was there between those, and we also want to know the idle time. I want to know. Meanwhile, because we can walk and chew bubblegum, let's check out patrol and find out why we're hanging up at target reached. The heck is it? Ah, okay. It's a... that explains a lot. No, that's not what I was using, though. It was a signal that was over here. Link reached. Navigation finished. Signals that the agent reached the target, i.e. the agent moved to the... What's the difference between navigation? So the idea here is that we were doing it right. Target reached. What the heck? Sure, patrolling. But what the heck is going on here? All right, let's leave this where it is. So we're going to let's take a... What the heck? Why is this only 8? I multiplied it by 1,000. What is it by itself then? If it's what is the number? How small it... Oh no. I don't know. This is crazy. This number right here is that number that I multiplied by 1,000. I think we have some inspector nonsense happening. All right, let's go back and change it. It's over here. Okay. There we go. So let's go here and say that it's 8 seconds that they can go idle for. That's 1. So it was inspector nonsense going on. Basically, the inspector was reading it at 0.0008, and then I was multiplying. That's why I was getting back 8 every time. It's crazy sometimes out here. It is crazy. Like, it's bizarre. So here's the thing. It's hard to describe it, but basically, when you do a getter,
and you have something that's exposed, the property that's exposed, and you use do a getter and you change the property in the getter by some value, it's actually also executing a setter in the inspector if you change the value there. Which makes sense, right? The problem is that you weren't calling get when you do the change on the inspector, but it's running it. And that makes it increase the set, because for some reason set does get, and it will set the value to whatever the amount is. So in that case, I was multiplying it by 1,000. So, and since the range is between like 1 and 30 or something like that, it would immediately just shoot to 30. But that's through the inspector. Programmatically, I'm assuming that it was going to work perfectly fine. On the flip side, then dividing the value that's returned by, or multiplying it by a decimal in this 1,000th place, would then make the getter come back with just the plain number at 0.00008. Oh, you can't win. It doesn't make any sense. You just got to multiply it inside of the method. Okay, so this doesn't work at all, right? Even when the agent reaches that position. So we're gonna do a thing. Bear with me. My heart is there in the coffin with Caesar. Okay, where is it? There we go. So we're gonna try doing it the Godot way. I think it's velocity computed, and we want to connect it to that. And we also want to turn on where is it? Yeah, you want to turn avoidance on. Right? And it should be at like the bottom, I guess. Yep. That is a terrifying amount of code up there. Right. So basically, we want to do this. When I don't think we need to. I think once we set up avoidance, it should do that. Right?
Okay, let's try that now. Oh, I had the screen. My bad. Didn't realize I had the screen running. So the first one... Okay. I think I'm going to call it soon. I just want to get at least patrolling working using this new system. Oh boy. What the heck, man? It was working before, I think, right? Let me take a look and see how I handled it. Hopefully I didn't delete it. Yeah, all I did was use set destination. While in neutral is patrolling. Set patrol destination. Oh, I was manually calling it. Wow. It wasn't working to begin with. I was actually manually calling it so that way this could get through. Okay. Looks like we're gonna have to use run. Where are you? Control. Okay. Is this even running? Print. Okay. Yep, it's running. Did they move? No. No, let's... Ah, doesn't have one. Interesting. It's harder, man, than I realized. It's crazy how that signal does not seem to function. Like, I'm looking at it visually on the debug. Well, at least we know the behavior system is working. That is pretty cool. I don't think I like that though. And they all just stopped moving? Why? No, they're doing something. Some of them are doing something. Yeah, it's not a valid system. It's not a valid approach at all. Hmm. Yeah. What time is it? Holy cow. Okay, yeah, it looks like it's gonna be time to call it there. But yeah, we have a functional behavior system that we can just drag and drop nodes onto, or sorry, resources into to get to work now. So it's just a matter of writing up the different resources and then testing them out and then applying it. So you can just interchange logic for different situations that way now. And it's something that can be scaled out, which is good. I'm going to call it here, though. I guess in part 3, I want to. Well, actually, probably off screen. I'm not even sure if I'm going to do it on stream. So off stream, I'm going to refine this part of the system and figure out what does it take to get the signal to actually function. I have this sneaking suspicion that so there was this thing over here. Enemy dungeon. There's this thing right here, which Let's go down. There we are. On navigation agent velocity computed. So it wants me to, I think, apply forces to, or changes to the velocity after the agent calculates velocity, which means that this is probably happening on the physics frame, but it's happening in such a way that it's after it's already accounted for the velocity of all the agents, I'm guessing. And this is supposed to be used properly for finding a safe velocity, I guess. Right? The problem here, though, is that we don't control the body here. We control it on the floating capsule. Right? And the floating capsule, so the only thing that I could think of to, I think the floating capsule handles it on its own run, if I remember correctly. Or is it being actually, no, it's being handled by the state machine. It's being handled by the state machine. So the state machine is taking that and putting it into that process. Instead, what we want it to do is we want it to handle it inside of this event. So the only thing that I could think of to try to fix this is to create a angle on the state machine for adding states that want to be calculated via this. So that's something I can take care of tomorrow. Yeah. So basically what it's going to be is that on the state machine, we're just going to treat it almost like an event. Well, it is an event. And take in the vector 3. Is what it looks like. I gotta find out what that vector 3 is, though. I'm not too sure. I'm gonna look up some examples of how this is used. And then after this is done, it will take care of sending the updates to the floating, because the floating capsule doesn't actually execute on the it doesn't have a physics update on its own, right? It doesn't do that. It only has the only thing that it handles is updating the 3D models, or sorry, the node 3D's position. That's it. It just maintains that, so it shouldn't be too big of a deal. That's tomorrow. All right, that was good. Thank you one and all. Have a great day, and hopefully this was a good shot at approaching. I don't know if it's a good approach, but it's my approach. All right, take care.